Howdy folks, we're about to start a new unit now in pre-calculus on rational functions and rational expressions. And let me explain what a rational expression is, just in case if you're not sure. A rational, hang on a second, rational expression or rational function or rational term, that sort of thing. When you see the word rational, that comes from the word ratio, okay? And a ratio is like, 4 to 7, or 4 to 7, or 1 to 5, or 5 to 3, something like that. It's a relationship between two values, a ratio, okay? You've seen that before, and ratios can be represented as fractions, which is why a rational expression or a rational function can also be understood as a fractional expression or a fractional function. Now, the thing that makes it a little different than just your regular everyday fraction is that a rational expression, or what I consider to be a rational expression or a rational function, or a rational function that you can graph that makes it different than other fractions, is that in a rational function or a rational expression, you typically have a variable in the denominator. So for example, 5 over x is a rational expression, okay? And if we had a function that was y equals 5 over x, this is a rational function. On the other hand, if you have y equals x over 5, even though it's a fraction, this is actually not a rational function. This is a linear function. See, we could take the 1/5 out and we could make it 1/5 of x, and now it's 1/5 of x to the first power. So this is a linear form right here. So even though it's a fraction, it is not a rational function. Rational functions have variables in the denominator. See, we could take this one apart, but it would become 1 over x times 5. We still have the x in the denominator, okay? So what we're going to be doing is we're going to be dealing with rational expressions. And we'll talk about, in class, we'll talk about why do we have rational expressions, what are they useful for. But in these videos, I'm just going to focus on how we calculate and how we do different kinds of techniques dealing with rational expressions. So here's the first thing that we have to talk about. It's very, very important that you understand this very, very important concept. And that is that because we have a variable in the denominator, let's say we have 4 over x, there is a rule in math that it's just a really important rule, okay? Especially dealing with division. You probably learned this a long time ago in elementary school, but the rule is you can't ever, never divide by 0. You can't do it. You just, whenever 3 divided by 0, undefined. 7 divided by 0, undefined. 0 divided by 0, don't even get me started. Indeterminate form, we're not even going to talk about 0 over 0 in a pre-calculus class. You can save that for a calculus class, okay? So, because the denominator cannot equal 0 ever, rational functions introduce this idea that there are values that x can't have. And in this particular case, what can x not be equal to? If we have 4 divided by x and we can't divide by 0, then x cannot ever be what number? 0, right? And the way we would write that is we'd put a comma and then we would say x, and then we'd put the not equal symbol, not equal 0. X cannot equal 0. So 4 over x, x can take on any value, 5 billion, negative 17 trillion. It can be 0.0001 if it wants to. Any number. X can be the square root of 7, okay? But it cannot ever be 0. So what you're going to see a lot in this section, and in almost every problem that you do, you are going to have to put a clause, a statement after your answer that tells you what x cannot be equal to. Very, very important. So now, let's do one more example of that. What if we had 7 over x minus 2? Now in this case, x can equal 0, because 0 minus 2 is negative 2, and it's okay for the denominator to be negative 2. But what can the denominator not, or what can x not be? Because the denominator cannot be 0, what number would make x minus 2 equal 0? Well, we can find out by setting the denominator, x minus 2, equal to 0 and solving. If we add 2 to both sides, we get x equals 2, right? So if x equals 2, 2 minus 2, that would equal 0. We can't have that, therefore x cannot equal 2. Okay, are we good with that? Let's do one more. I know I said we were only going to do one more, but I just had a thought we should do maybe just one more. What if we had 6x over 3x plus 4? Now what could x not ever equal? Well, what we would have to do is we would have to set the denominator equal to 0 and find the 0. So 3x plus 4 equals 0, minus 4, we get 3x equals negative 4, divide by 3 on both sides, and when x is negative 4 over 3, the denominator would equal 0. Therefore, x cannot equal negative 4 over 3. That is a very important concept that you need to understand. Okay? All right, now that we understand that, let me tell you what it is that we're going to learn in this particular video. In this video, we are going to learn how to add rational expressions. How to add rational expressions. Okay? All right, so, well, let's add fractions real quick so that we can remember how to do this. What if I gave you 3/5 plus 4/7? Do you remember from 4th grade, 5th grade, whatever, how to add these together? You cannot add these together unless, in this form they cannot be added together, because you can only add fractions that have a, what's it called? A common denominator. The denominator has to be identical in both of the in both of the terms in order to add them together. So here's what we're going to do. In order to get a common denominator, we need to change this denominator and we need to change this denominator. Now, in order to make sure that this stays 4/7, when we change the denominator, we're also going to have to change the numerator. Same thing over here. When we change this denominator, we are going to have to change the numerator as well so that it stays the same value. Okay? So typically, one of the greatest techniques in all of math is the idea of multiplying by 1, because when you multiply by 1, your value stays the same. So we're going to multiply 4/7 by 1. And I know what you're thinking. You're thinking, yeah, but Mr. Ryan, if you multiply 4/7 by 1, you just get 4/7 and nothing changed. Right, I understand that. But understand that the number 1 can be represented in a lot of different ways. For example, 3 over 3 is equal to 1. 19 over 19 is equal to 1. X over x is equal to 1. 7x minus 9x squared over 7x minus 9x squared is equal to 1. As long as we create a fraction that has the same numerator and the same as the denominator, okay, then that fraction will equal 1, and then we can multiply it by the fraction that we have. So, here's the thing. This denominator has a 5, and this denominator doesn't have a 5. So this denominator needs a 5. So what we're going to do is, we're going to multiply by 5 over 5, because 5 over 5 is equal to 1, and we need to introduce a 5 to this denominator. Now, This denominator has a 7, and this denominator does not have a 7. So we want to introduce a 7, so we're going to multiply by 7 over 7. Now when we do our multiplication, if you remember how to multiply fractions, you just multiply straight across. 7 times 3 is 21. 7 times 5 is 35. Plus 4 times 5 is 20. 7 times 5 is 35. And by having done this procedure, we now have a common denominator, and now we can add our numerators. When we add fractions, we add just the numerators, and we just carry over the common denominator. Well, the common denominator that we're carrying over is 35. We are not combining these numbers here. This is the common denominator. It just stays 35. We're combining the numerators. 21 plus 20 is 41, and 3/5 plus 4/7 is equal to 41 over 35. Okay? So now, understanding this, remembering this from 4th or 5th grade, we can now learn something about rational expressions, expressions that have variables in the denominator. So let's do our first example. Let's say that we had 3 over x plus 6 plus 7 over x minus 2. All right? Now, the first step in doing these kinds of problems, the very first thing that you always want to do is you want to factor the denominators. Okay? Denominators. So if the denominators are like x squared something or other, if they're not already just a binomial, a linear binomial, then you may have to factor it down. In this case, we do not have to factor the denominators. Okay? So we can skip step 1. Now step 2 is I'm just going to say multiply by 1 in a different form. Okay, here's the part where you're of a different form to create common denominator, a common denominator. So in step 2, your goal is to create a common denominator. Here's what you're going to ask yourself. What does this denominator have that this denominator does not have? Now, be careful here. I know what you're thinking. Well, they both have x's, but this one has a 6 and this one has a -2. No. We are not dealing in addends. We are not dealing in subtrahends. We are not dealing in addition and subtraction. We are dealing in factors, things that multiply. This, so I recommend you put parentheses around this. We are dealing in factors. And so now the only thing in this denominator is the factor x minus 2. That's one thing. X minus 2 is one thing. And x plus 6 is one thing. So this denominator has an x plus 6. This denominator has an x minus 2. So what does this denominator need? It needs an x minus 2. And this denominator needs an x plus 6. So what we're going to do is we're going to multiply on this side. We're going to multiply by x plus 6 over x plus 6. So watch this. X plus 6 over x plus 6. And on this side, we're going to multiply by x minus 2 over x minus 2. X minus 2 over x minus 2. Now, we can introduce an x minus 2 here, and we can introduce an x plus 6 here. And now, we're going to multiply. So, now here's the thing. Step 3 is leave denominators in factored or in factor form. What I mean is this. Do not multiply out the x minus 2 times the x plus 6. Just leave it as, watch this. We're just going to leave x minus 2 times x plus 6. That's the denominator for this one. Plus, again, x minus 2 times x plus 6. Because remember, when you multiply fractions, you just multiply straight across. This times this. This times this. So that gives you this. We're just going to leave it as factored form. Now, the numerators we're going to distribute. So over here, we can do 3 times x and 3 times negative 2. Well, 3 times x is 3x. 3 times negative 2 is negative 6. And now, 7 times x is 7x, and 7 times 6 is positive 42. Got it? Next step, combine. Combine means add together, okay? Add or subtract. Combine the numerators. Okay, we're going to combine the numerators. And so now, so what this is going to be equal to is the denominator. So we're adding this plus this. All right? The denominator, which is the common denominator, just comes down as x minus 2 times x plus 6. Okay? The numerator, you remember, you can only combine like terms. That means terms that have the same letters to the same powers. Or you can combine terms that don't have letters at all. Okay? So this 3x cannot be combined with this 42. And this negative 6 cannot be combined with this 7x. We can only do 3x plus 7x. And 3x plus 7x is 10x. And then negative 6 plus 42 is 36. So we'll put plus 36. And we're pretty much done. That's it. That's your answer. Now, we're not quite done with what we're going to write down, but that is your answer. Okay? So after you combine the... now, here's the other thing. The last step, you have to identify domain restrictions. Okay, and that's what I did before at the beginning of this video where I say x cannot equal. Well, what can x not equal here? What can x not equal? Well, here's the deal. Since these two factors are being multiplied, if either one of them was 0, the whole thing would be 0. If this was 0, 0 times anything is 0. If this was 0, 0 times anything is 0. So what value would make x minus 2 equal 0? What minus 2 equals 0? Positive 2, right? 2 minus 2 is 0. So x cannot equal 2. What else could x not equal? What number plus 6 is equal to 0? Negative 6, right? And what you could do is you could take this x plus 6 down, set it equal to 0, and then solve for x. Cancel if x is equal to negative 6. So x cannot equal 2 comma negative 6. Because if x was equal to either one of these numbers, then the denominator would equal 0. And we can't let the denominator equal 0 because it's illegal in math for the denominator to equal 0. Okay? All right. Let's do another example. Now that we've got our procedure here, we should be able to go through it a little bit quicker. Let's step up. Let's go up one step here. Okay? Let's do 7x. Let's do 7x over x plus 1 7x over x plus 1 plus 8 over x minus 5. Okay? All right, first thing we're going to do is we're going to factor the denominators. Well, they're already factored. so we don't have to factor the denominators. All right, so now what we're going to do is we're going to say, well, what does this denominator have that this one doesn't have? It has an x plus 1. So we're going to multiply by x plus 1 over x plus 1. Over on this side, this denominator has an x minus 5. So we're going to multiply by x minus 5 over x minus 5, right? Now this is going to result in this denominator is just x minus 5 times x plus 1. The numerator, though, we're going to do 7x times x is 7x squared, and 7x times negative 5 is negative 35x, plus this one, again, x minus 5 and x plus 1, x minus 5 and x plus 1, right? Numerator, 8 times x is 8x. 8 times 1 is plus 8. And now we're going to combine like terms in the numerator. Now look at this 7x squared. I want you to notice, no x squared here, no x squared here, no x squared here. So there's no combining. We're just going to bring down the 7x squared. 7x squared. Here we have a negative 35x and a plus 8x. Well, negative 35x plus 8x is going to be negative 27x. Okay? And lastly, see this plus 8? There are no other constants. That's what we call a number that doesn't have a variable, a constant. There aren't any other constants, so we just bring down the plus 8, draw our fraction line, put the common denominator, x minus 5, x plus 1 on the bottom, and we're almost done. Now we just need to identify our domain restrictions. What can x not equal? X cannot equal what minus 5 is equal to 0? 5. So x cannot equal 5, and what plus 1 is equal to 0? Negative 1. So x cannot equal 5 or negative 1, and we're done with that problem. Okay? Let's try another one. Let's try one where we have to factor the denominator. All right? Let's say that we have x minus 3 over x squared plus 7x plus 10 plus 4x over x squared plus x minus 2. Now, step 1, factor the denominators. Now, if you need help with factoring, we don't cover factoring in this class. The assumption is that you already know how to factor. But if you need some help with factoring, you can find one of my videos on factoring. I actually have, I think, 6 different videos on factoring. And the one you're going to want here is the video on product sum factoring. Okay, this is basic product sum factoring, but you have to know how to factor to be able to solve these problems. If you do not know how to factor, you have to go back and refresh yourself on factoring. It's a required skill for this class. So now, so we're going to factor here. We're looking for 2 numbers that multiply up to 10 and add up to 7. Let's see, 5 and 2. 5 times 2 is 10, and 5 plus 2 is 7. So this is going to factor to x plus 2 and x plus 5. Okay? This one, 2 numbers that multiply to negative 2 but add up to positive 1. Let's see. Positive 2 times negative 1. Positive 2 times negative 1 is negative 2. And positive 2 plus negative 1 is positive 1. So our 2 numbers are positive 2 and negative 1. So we're going to have x plus 2 and x minus 1. Cross that one out. And so now, here's our denominators. Now we've got to ask ourselves, what does this denominator have that this denominator doesn't have? Well, this one has an x plus 2, but this one also has an x plus 2. So we don't have to put an x plus 2 in. This one already has it. But this denominator has an x minus 1, and this one does not have an x minus 1. So we're going to multiply by or sorry, not on this side, we're going to multiply on this side by x minus 1 over x minus 1. What does this denominator have that this one doesn't have? Well, this denominator has an x plus 5, and this one does not have an x plus 5. So we're going to multiply over here by x plus 5 over x plus 5. And now we can carry this stuff over. Now we have three factors in the denominator. We got x minus 1, x plus 2, and x plus 5. We're going to cram all of them into the denominator. X minus 1, x plus 2, and x plus 5. Plus, same thing for this one here, same three things in the factors in the denominator, x minus 1, x plus 2, and x plus 5. There we go, because we multiplied by x plus 5 here. Now let's go to the numerators. Over here, it looks like we're going to have to do some distribution. We're going to have to FOIL that, or whatever you want to call it, okay? We're going to have to multiply x times x, which is x squared. Then x times negative 3 is negative 3x. Then negative 1 times x is negative x. And then negative 1 times negative 3 is positive 3. We got negative 3x minus x. We got to combine that. That makes negative 4x. So let's go ahead and fix that. So this is now minus 4x plus 3. And so now that one's done. Over here, the distribution is not so difficult. We're going to do 4x times x is 4x squared. Then 4x times 5 is plus 20x. And now we just add the numerators. We've got an x squared here plus a 4x squared here. X squared plus 4x squared is 5x squared. Then we've got a negative 4x plus a 20x. So negative 4 plus 20 is 16x. And then over here we have a plus 3, but there are no constants over here. So it's basically 3 plus 0, which is just 3. That's our numerator. And then just carry down the common denominator, or carry over the common denominator. X minus 1, x plus 2, and x plus 5. Last thing, and we're done. What can x not be equal to? Well, now we have three factors in the denominator. So there are three ways that the denominator can equal 0. For x minus 1, the 0 of x minus 1 is positive 1. The 0 for x plus 2 is negative 2. And the 0 for x plus 5 is negative 5. And so now this is our solution for the sum of those two rational expressions. All right, so that's it for adding rational expressions. Watch my next video on subtracting rational expressions. We'll probably do about 3 examples in there, okay?